Hello friends, today we will be discussing about derivative of functions in parametric form. Let us first understand what is a parametric form. If x and y are two variables such that they are connected or explicitly expressed in terms of third variable, say t, that is, if x is a function of t and y is also a function of t, then such functions are called parametric functions. And the third variable t is called a parameter. How do you find out the derivative of such functions? First, we can write dy by dt as dy by dx into dx by dt. So dy by dx may be written as dy by dt upon dx by dt, provided dx by dt is not equal to 0. This is what we are supposed to do. Now let us take an example. If x is equal to a cos theta plus theta sin theta and y is equal to a sin theta minus theta cos theta, find dy by dx. Differentiate both with respect to theta. So for x, dx by d theta, apply the rule of the derivative here. So derivative first function, again derivative of second function, and second function is a product of two functions. So here we will be applying the product rule. Derivative of cos theta is minus sin theta, and product rule, theta derivative of sin is cos and sin theta derivative of theta is 1. So you are getting that minus sin theta plus sin theta, they get cancelled and you are getting a theta cos theta. Now dy by d theta on the same line, d theta of sin theta cos theta, apply product rule, minus first function derivative of cos is minus sin theta and minus cos theta derivative of theta is 1. Again you can cancel out cos theta. You are finding a theta sin theta. Now dy by dx is dy by d theta upon dx by d theta. So dy by d theta you have got a theta sin theta and dx by d theta you have got a theta cos theta. You can cancel out a theta, so you are getting tan theta. So you have been able to find out dy by dx. Let us take another question, and very important. If x is equal to a sin 2t, 1 plus cos 2t, and y is equal to b cos 2t, 1 minus cos 2t, we need to find out dy by dx at t is equal to pi by 4. So first we will find dx by dt. Dx by dt is, now again you have product of two functions. So a first function derivative of 1 is 0 and cos is minus sin 2t and 2t is 2. Second function 1 plus cos 2t. Derivative of sin is cos 2t and derivative of 2t is 2. So you are finding, take 2 out, cos into cos is square 2t, sin into sin is square 2t, and cos 2t into 1 cos 2t. And you know cos square x minus sin square x is cos 2x. So we can write this as cos 4t and then cos 2t. So you are getting 2a, 2 cos 3t cos t. So you can write this now as cos 4t plus cos 2t is what? You can apply that rule. 2 cos c plus d by 2 and cos c minus d by 2. So it gives you this. So finally you are finding dy by dt as 4a cos 3t cos t. Now we will be finding out dy by dt. On the same line, apply the product rule. First function derivative of cos is minus, so minus minus plus sin 2t, and then derivative of 2t is 2. Now second function derivative of cos is minus sin 2t and for 2t it is 2. Take 2 out, so you have got sin 2t cos 2t and minus sin 2t here, minus minus plus sin 2t cos 2t. So it gives you 2 sin 2t cos 2t, and you know the formula. 2 sin x cos x is sin 2x. So it is sin 4t. Minus sin. Again you can apply sin c minus sin d rule. So it gives you 2 cos c plus d by 2 and c minus d by 2. So it is giving you 4b cos 3t sin t. Now dy by dx again, dy by dt upon dx by dt. So you are getting 4 cancelled, cos cancel, b by a tan t. But you have been asked to find out dy by dx at t is equal to pi by 4. So you will be replacing t by pi by 4. So b by a tan pi by 4, and tan pi by 4 is 1. So you have got your answer as b by a. One more question, we will be taking different type of question. Here you have been asked to differentiate this function with respect to this function. Now it is not directly that you have been asked to find out dy by dx, but you have been asked to differentiate this with respect to this. So what we have to do, we'll assume these two functions as y and z. First is y, second is z. Now before you go and find out the derivative with respect to x, just think of whether you can simplify the functions, and especially when you are having an inverse, you must think of simplifying it fast. So it can be simplified. If we are taking x is equal to tan t, then t will be tan inverse x. So under root 1 plus tan square minus 1 by tan t. And this gives you sec t minus 1. So sec is 1 by cos. And tan can be written sin by cos. Cos gets cancelled. You are getting 1 minus cos by sin. And 1 minus cos is 2 sin square t by 2. And sin t can be written 2 sin t by 2 and cos t by 2. 2 is cancelled, sin is cancelled. You are getting tan inverse tan t by 2. So tan inverse tan is half t, t by 2 we can write. So we have got this as half tan inverse x. Now z, sin inverse 2 tan. Now let us put x is equal to tan theta here. So sin inverse 2 tan theta by 1 plus tan square theta. And this is sin 2 theta, we can write sin inverse sin 2 theta. So sin inverse sin 2 theta can be written as 2 theta. So it is 2 tan inverse x. They have got a relation now. So we can write y is equal to half tan inverse x, and tan inverse x here is z by 2 or half z. So 1 by 4 z. So now you want to differentiate first with respect to second. So dy by dz. 1 by 4. For z you can write 1, so it is 1 by 4. Otherwise you could have done it here only. You could have found dy by dx, here also dz by dx, and then you would have divided dy by dx by dz by dx. It would have given you the same thing. Both way you can try it out. So this is how we approach further questions in parametric form. Thank you very much.